Gaffney, and this is Physics 2, Lab 1, all about charged U-tapes. So, what is the problem we want to solve in this lab? It is how a charged piece of tape interacts with other charged and uncharged objects, including other tapes. And why we want to solve this is it's a real-life demonstration of charged objects interacting with each other, which is relevant to what we're learning in class. And we can begin our understanding on charging an object and how that can exert a force on other charged objects. So here are the physics principles used in this lab. We have the electric field, which is KQ1 over R squared times R hat. We have the electric force, which is the electric field times Q2. And then the force of gravity, which is mg right there. And then here's the setup of the lab. We have the two water bottles. And then we have the charged U-tape sagging between them, ready to be repelled with the other tape. So the actual experiment itself, we start with one U-tape, we charge it, hang out the side of a table, and then see how it interacts with other charged and uncharged objects to figure out what the charge of the actual U-tape is. So it was seen to attract both my hand and the what we knew from the instructions, which is a negatively charged pen, which leads us to deduce that the tape is positively charged. And that leads into the real experiment, which is interacting two positively charged U-tapes with each other, and seeing how that electric repulsion will combat the force of gravity. So we basically bring the other charged tape under the hanging charged tape, which you guys saw in the last slide, and the repulsive force will raise it up until it reaches equilibrium with gravity. And then we measure that distance, and from there we can figure out the charge on the tape. So system and surroundings, initial conditions. System is the hanging tape between the two water bottles. The surrounding is everything else, including the other tape and the earth, which will exert forces on it. And the initial conditions are the hanging tape is charged and only the force of gravity is acting on it. So here's my glow script model. This green arrow is the force of gravity, and these orange ones are the electric force of these two interacting with each other. This top one is obviously the top tape, which we're mainly observing, and then here's the other tape. And then here's just kind of my code. I got some arrows in there, and that's just kind of behind the scenes. And I also had to print out the charge on the tape, which I got this number right here, which is very similar to what we see in a second, which is the experimental value. So here are the results of both. In the experiment, we found the mass of the hanging tape was 0.00081 kilograms. And I found that by finding the length of the tape. The distance between the two tapes at equilibrium was 2 centimeters. Um, the force of gravity on the hanging tape was 0.0018 newtons. The charge on the tape I found after doing all the calculations over here um, is 9 times 10 to the negative ninth coulombs. You can see that right there. The number of electrons is 5.54 times 10 to the 10th deficit. The number of atoms is 3.6 times 10 to the 17th atoms. And the ratio of electrons to atoms is 1.54 times 10 to the negative 7. And then you can see the charge on the tape in the glow scoop model is 8.86 times 10 to the negative ninth coulombs, which is very close to this number right here. So what if electrons had positive charge and protons had negative charge? Well, what would change about the observations you made with your tapes and other charged objects? If the charges of electrons and protons were flipped, then my tape would have a negative charge, which means they would be repelled by a negatively charged hand and the negatively charged pen. Since the tapes still have the same charge as each other, they would still repel each other the same as before, meaning this would not really have a huge impact, or really, it wouldn't have any impact at all on the lab we're performing. So why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? It's important to handle the charged tapes as little as possible, especially with other charged objects, since the charge can transfer and it will become uncharged pretty easily. So you want to preserve the charge so you can see what happens in the experiment. So if you touch it with your negatively charged hand, the electrons will transfer from your hand to the tape, basically making the tape lose its charge. And similarly with other negatively charged objects. Um, so yeah, it's best to leave the tape alone as much as possible. Conclusion. So assumptions made. We ignored air resistance, treated the U tapes as point charges, and assumed the U tape had about the same amount of evenly distributed charge. And improvements you can make is you could wear some sort of gloves in your hands that prevents the transfer of charge with U tapes. Thank you.